The topic says, how clean is your app? So before going to start, let me introduce myself. Uh, I'm currently working as a senior engineering manager in Times Internet with the Central Mobile Applications team, leading their platform project initiatives and closely working with the Dynout team, leading apps development as well as architectural improvements. So let's start. Now, I wanted to start with a very common, term. It's like whenever we come across like any architectural debate or probably any kind of refactoring episodes, one thing that comes to our mind is basically how to get rid of a very huge class or probably the God class. The name, as the name suggests, God, it knows too much or it does too much. It's a very famous term in a bad programming. Whenever we say bad programming practices, this is something which pops up more frequently. It's basically a huge class in terms of number of lines of code. It creates tight coupling and increases the challenges in the code maintainability. Now, having said the that yeah, this is a God class or probably yeah, this is something that is very complex. So how can we detect a God class? It's very simple. There are few characteristics that you can apply, that you can identify while you are reading in class. Generally, they are very large and complex, and they heavily access data of other simple classes either directly or using some accessor methods. They have a lot of non-communicative behavior. That is, there is a low cohesion between the methods belonging to that class. So these are some of the bare minimum characteristics that you can find whenever you encounter a God class. So I think no need to explain about cohesion and coupling, but what we say about modularization and all. So often a low cohesive and a high couple code is considered to be a bad modularization, while a high cohesion as well as low coupling is considered to be good modularization. Going forward, like what's in an application? Like if we say, yeah, we need to define the term application. So what is actually inside an application? As per Uncle Bob, an application is nothing but a group of use cases that describes the intent of the application and a group of plugins that give those use cases access to the outside world. So if you can see, I have highlighted few words: use cases, intent, and the outside world. So what's in a good architecture then? So architecture, as the name suggests, is the shape of the system. It supports the behavior of the system while keeping its flexibility to most of the changes. Hence, a good architecture is scalable, flexible, and maintainable. So architecture is the blueprint of any software application. So if the blueprint or probably the uh, basement of the software is not good or probably it's not well defined, as the project grows, as the project scales, it's very difficult to maintain, and also the flexibility to change is very less. Now, how do we ensure that our architecture is designed or probably maintained or probably thought of or probably planned in a cleaner way? The clean architecture is something to a rescue. It's not very new. It's very popular. It has been here since a very long time. But often what happens is we end up using the clean architecture in a different way, and probably we end up into a monolith eventually. So in this talk, I'll basically walk you through different steps slowly and gradually where you can end up to a very cleaner way of defining your architecture. We'll see some examples wherein we'll apply the clean way and also see how clean way can help us in maintaining our software quality as well as scalability. So if I talk about the clean architecture, majorly it revolves around abstraction and separation of concern. So this has been the main motto of the clean architecture, where you will find lots of abstractions and definitely there will be separation of concern. So at the heart of clean architecture lies the business logic. The business logic knows nothing about the outside world, the UI, the libraries, the frameworks, the platform, data source, etc. It's platform agnostic, it's library agnostic, it's framework agnostic. So the heart of clean architecture is the business logic. So how to achieve this? Now, there is a dependency rule. I know most of us have encountered the onion architecture, and this onion, trust me, will not bring tears to your eyes. So the dependency rule suggests all the inner layer should not know anything about the outside layer. So if you see the arrows inside, it's going from outside to in. So dependency always move inwards. Now, uh, this is basically kind of abstraction. I would say very confusing, or probably what are the devices, what are the gateways, entities, which are called entities, which are the use cases, presenters. All this stuff is very kind of abstracting. Now, let's try to apply this in uh, our Android application point of view. Now, herein, you will see the major parts, or probably the major layers that clean architecture bring to us is basically three. There can be multiple layer. We can break the data layer into repository as well as data source, but for the sake of simplicity and for the understanding purpose, I have kept it to three. So it starts with the presentation layer, where, as the name suggests, it's all about the view, how we use to present our data to the view and how the view will look like. There is a domain layer, which is the business, which handles the business logic. And there is a data layer from which we fetch the data. Now, if you see the arrows denotes the dependency between these three layers. So the presentation layer knows about the domain layer, and a data layer knows about the domain layer. So if you see, domain is something which is independent, or probably doesn't depend on any of the outer layers. Now, coming back. So there is a concept called dependency inversion. Now you might question, like, why presentation depends on the domain, and why not domain depends directly on the data layer. Most of us, what we do is we start off with this clean architecture approach, but somehow we lost the dependency flow. This particular thing will it's bound to, people are more prone to violate this principle, the dependency inversion principle, wherein from the use cases that directly access the repositories. Now, what is the harm of doing that? Let's suppose there is a use case and you want to use one repository for fetching some data. Now, on the later stage, you want something to be the source of truth for that particular data. You want to replace it. How will you do it? You will directly go and modify the use case, right? Because use case is directly coupled to the repository, and inside the repository, the implementation gets changed now. So what dependency inversion says? Dependency inversion says, like, all the higher level modules and the lower level modules, the use cases are higher level, the repositories are the lower level. They should not depend directly on each other, rather than they should depend on some abstraction. And the use case will depend on the abstraction repository layer. The repository is just the interface. So it will call the repository, and via some dependency provider will inject the repository implementation to the use case. Like this, what happens is, the use case, whenever there is a change in the repository implementation, the use case is not impacted. So this kind of dependency inversion is achieved while we use this kind of abstraction, implementation, and injection. So we should not directly use higher level, should not depend directly on the lower level. Now, coming back to the Android application point of view. Now, let's see how the event and the data flow in the application that we have defined just now. Of course, there is a view. By view, we can say it's an activity or a fragment or a simple view. The view will have an event passed to the view model. The view model, since the is a part of the presentation layer, so somebody might use presenter for that sake. But yeah, for the sake of most of us are using view model. So I have taken into consideration the example of the view model. So the view will ask some data from the view model, will ask for an operation in the view model, probably. The view model, since it's dependent on the domain layer, it will have a use case. So remember the application definition. So if I say I need to have an application, I need to have a group of use cases for a particular intent, right? And now the view model will pass some intent to the use case. Yeah, I want this data, or probably I want to process the data. The use case will call the repository. And this repository is nothing but an abstraction. So use case will call the repository. This repository is being implemented by the repository implementation. And finally, the repository will fetch the data and create a data model. I'll come to this, the data model part, why we have a data model and probably different models at different layers later on. Now, once the data is fetched in the data layer, the data model is being mapped by a data model mapper to a domain model, which is called a domain model. So finally, our business model is what we call the domain model. Now, the domain model then translates to translated by the domain model is translated by the UI model mapper, which converts back to the UI model. And this is the model that is being used by the view to render the data. So this is how the event and the data flow happens. So if you see, it starts from the view and ends from the view. So whenever a view requests a data, it will go up till the repository layer, and from the repository layer back to the view. But at any point of time, you will not find any breakage in the dependencies. The dependencies remains the same. The presentation layer will depend on the domain layer, and a data layer will depend on the domain layer. Now, the question is, we know that how to basically break our application into layers. Now, how would the project structure look like? So there are multiple approaches. So there has been debate around multiple approaches, like whether we should go with a single module and have the clean architecture layers as a part of the single app module, or probably some separate module in terms of presentation, domain, and data. There are multiple pros and cons for each and every approach that will be defined here. Now, we can also have some hybrid approach. Like if we define a single module approach where we have an app at the top, and then it has divided the entire application into presentation, domain, and data. So here what happens is, since the app is basically an Android module, the separation can only be made by custom lint rules. We can't have that module segregation over here that yes, domain will be a completely application, platform agnostic stuff. But here, since we are defining it in a single app module, we don't have that module segregation happening. So a hybrid approach to the single app module is basically dividing the application into different features. So we have features. Let's suppose app is a feature, and inside the feature, we have all these modules. So this can be a kind of hybrid layering of your application, what you can say. Having a separate module, what enhances it, like what happens with having separate module is basically the domain can be made platform agnostic, because I can have a Java module or a Kotlin module inside my project structure, and I can help it to avoid any corruption of platform dependencies or such like that. This again further can be splitted into features. Like what happens is, like you can have a feature A domain, feature B data, feature B presentation. So there are multiple approaches to do that. Most of the time, we either move between these two. The hybrid approach are seen, like let's suppose we need to have some dynamic plugins or dynamic feature delivery. So that you can achieve via having a layering your application by feature. And inside the feature, you can have data, domain, presentation, all these layers. Now, some of the basic design principles that are basically used while you will be considering or probably writing each and every class in your architecture or probably in your project. One of the very famous principle is the solid. First is S stands for single responsibility principle, which ensures one and only one reason to be changed. So if we have a class and that class is responsible for doing a particular stuff, then that class should be revisited or probably refactored only for that one particular thing that it is responsible for. So that is what the single responsibility principle states. Open close principle, it's enable adding new functionality without changing the existing code. So it is often realized that for every new or probably every incremental feature to a particular project, it requires rewrites or probably the ultimately eventually the class turns out to be a God class. So open close principle helps us to define our class in such a way that it can be extended easily for adding some new functionality. We'll look into the examples later on. Third, Liskov substitution principle. Simple as that, derived class must be completely able to substitute its base class. So if you have a class that is derived from a particular parent, that child can replace the parent entirely, not partially. This is what Liskov substitution principle suggests. Integration segregation principle, it ensures interface members to have very high cohesion. So whenever we define an interface, like we have different abstract methods or probably different responsibilities that needs to be performed by the class that implement an interface. While defining the interface, we should take care of the fact that all the cohesive functions should be aligned to a particular interface. And if we have a different responsibility, then probably we need to decouple it to a different interface. This is what the interface segregation principle suggests. And no client should be bound to implement anything which it doesn't want. Last but not the least, the dependency inversion principle that we have just shown in the while we define the different layers. Details should depend on abstraction. All the high level and the low level modules should not depend directly. It should depend to a abstract layer. So these are all about solid principles. We'll look into each one of them examples later on. There is another principle called a dry. So dry is nothing but don't repeat yourself. So every piece of knowledge or logic must have a single unambiguous representation within the system. We should divide our system into pieces, code and logic into smaller reusable units, and use that code by calling it where we want. So what basically the principle suggests, whenever we write a particular piece of code and that piece of code needs to be used somewhere else, the source of truth should remain the same. We should not repeat the same piece of code each and every time, basically the use case, we get any use case. What it prevents is, number one, you will have a single source of truth, number one. Number two, whenever there is a breakage, or probably if we have something that we need to fix or probably debug, we will have a single place for that fix or probably a patch. Don't write lengthy methods, but divide the logic and try to use the existing piece in your method. So you should reuse to the maximum. And obviously, less code is always good. Everybody likes less code. It's easier to maintain and easier to test. Another principle, KISS. This is basically the keep it simple, stupid. The abbreviation suggests. Now, what this suggests is that keep the coding simple and straightforward. Keep your methods small. Every method should only solve one small problem, not many use cases. So whenever we define a method, we should be very attentive that, yeah, this method is doing a particular stuff, not doing more than one stuff. If you have a lot of condition in the method, break them into some smaller methods or probably delegate. It can help find bugs a lot faster. Now, we have discussed about the clean architecture. We know how to layer our application into different approaches. We know how the dependency inversion works. We know the design principles. Now let's dive into some real life example and let's see how we can implement it in a cleaner way. A very simple use case. I need to load a list of user data from some service. And the one of the biggest advantage of clean architecture, which I personally like, is like delaying the implementation. Like I am not concerned about how the users list will be loaded, how the users list will be manipulated. All I need is some data to be shown to the view. Now let me define the use case a bit on a detailed way. The use case suggests that load me the list of users with the initials as the letter A. Let's suppose we have a list of users, probably in some remote source or probably in some local source, and they are all jumbled up or something like that. We have a raw user list, flat list of users. Now, I need to filter the list and show in the view only the users whose initials starts with A. So remember the data flow diagram, right? So event and data flow diagram. I have a view, and my view is having, it's a hazard relation, and it's having a view model. That view model is being provided with a use case, and that use case internally using a repository implementation that is being injected by the high level module. This all can be done via dependency framework, but for the sake of simplicity and for better understanding, I have used the constructor injection. So some view model, it requires some use case, fetch user use case, and that use case requires a repository implementation, and that repository will basically talk to a network data source. Now see the dependency. I have a view model in my representation layer. I have a use case in my domain layer. Now the repository implementation is basically in the data layer, but this fetch user use case is basically injected with a repository implementation, which eventually implements a repository, and that is in the domain layer. Now there is a view model which will ask the view will ask the view model to load the list of users, and the view does nothing. It just gets the list and it shows to the view. Always remember, when you define a view, the view should be as dumb as possible. The view should not contain any logic. All those permissions logic, and it's fine. But anything specific to business, anything specific to domain logic, it should not know anything about it. Simple, it should be having, because the ultimate goal, remember the term application. So application is nothing but a group of use cases which are defined to perform for an intent. So the intent of my application is to show a list of users having the initials name as A. So load UI, inside the load UI, there is a function called load UI, some function called load UI. And inside the load UI, I am just calling the view model loads is a list, and simply I am displaying the list. That's it. View model is doing nothing. It's just calling the use case. And as you can see, there is a mapper. So I'll let you know why this mapper is and what the role of this mapper. Now this fetch use case will call internally, we call the fetch user data get method for the fetch user data use case. And finally, we map the data to the user data view model, user view data model. So if we go further, you will see inside the domain layer, I have three things. One is the domain model, that is the user. I have a username, user ID, or the username. Now I have a repository. Repository is nothing but an abstraction, and it's a kind of service. Term is as a service, somebody calls it as a repository, and this is a kind of abstraction that the domain layer has right now. Now fetch user case depends on this abstraction, the user repository. So as you can see, the fetch user use case has a constructor variable called user repository, which is a type of this abstraction. Now what you can do is we can inject this user repository by constructor invocation or probably some dependency injection library, and we can easily replace the user repository with any other repository that we are basically planning to change in the near future. Remember the dependency, probably the list of substitution principle. So any repository that will implement the user repository should be completely replaceable by its child. So that is something which is called the list of subdivision principle. You can get it from here itself. Now, what the use case does, the use case fetches the data from the user repository, and you can see we get a raw user list. This raw user list is basically something that contains hell lot of data. And the main intent of our application, remember, is to filter the list and get the user list with the initials as A. Here the magic happens. So filter list is basically a method which is filtering the data and returning the only the list of users having the initials with starting with A. So now you can see this is our domain logic, right? So this domain logic, you can test it independently. You can have your own user repository, mockable user repository. You can mock the get method, and you can test this particular implementation. So this is how your domain layer will be designed for this use case. Now coming back to the data layer. So data layer will be having its own model. So let's suppose for the sake of convenience, I'm saying, yeah, this is a model that is being returned by our network layer. Now, as you can see, we can have multiple redundant data in the user data model, right? So the repository, the data layer might be fetching all the data, but our domain, the intent of the application is not to display any one of them, but yes, only the filtered data it wants. Now, whenever we used to implement a data layer, inside the data layer, you will see, since it depends on the domain layer and it depends on the repository, I will be having a user repository implementation, which will eventually extend the user repository. Inside the user repository, you will find a user data source. Let me tell you why I need this user data source. So user data source is nothing but an abstraction again. So we have an interface and the load users. Just imagine, let's suppose initially our product owner says, yeah, all the users, the list of users I'll be providing you in a file, and you need to query that file and probably load the list of data. And finally, in the view, it should display the list with the initials as A. Later on, what happens is like the product owner says, hey, it's very difficult to maintain the Excel file. Now let's migrate this Excel file to the backend and let's fetch the data from the network. Now, what will change? Only the data source that is being injected by the higher module while defining the user repository will change. So instead of the network data source, I will provide instead of the local file data source, I will provide a network data source, and rest everything remains unimpacted. Having said that, the user data source implementation should be perfectly replaceable by any one of the class that implements the user data source, the Liskov substitution principle. So this is how the data layer will behave. Now, again, there is a mapper. That mapper will basically map the data layer model to the domain layer model. So you can see the method user repository is the get method for the user repository implementation is returning a list of user. So data source load users is returning a user data model. We need to map it because our domain doesn't require all the redundant data for for displaying it in the view, or probably the intent of the use case or probably the intent of the application has nothing to do with the other fields. So the user ID can be avoided, but just for the sake of some simplicity, and probably I am using that user ID. Probably later on, I need to have some filter based on the user ID as well, and probably the user ID needs to be displayed. So these kind of things can be done, but yeah, we can avoid the user ID as well from here. So this is how the data flows. Now let's go back and see how we can relate to this. So what I'll be doing is now my view asks the view model for loading me the list of users. The view model will ask a use case that, hey, please give me the list of users that starts with initials A. It will call a repository. It will call some method in the repository. and it will fetch the entire list of users from the repository. Now there will be a data model. Inside the data model will be having a list of users having all users data. The data model wrapper will map the raw list into the domain model. Now the domain model will be filtered accordingly by the domain model wrapper, and it will be consumed by the view model. And inside the view model, I am having a UI model wrapper that eventually will transform into a UI model. So now you can relate how the data flow happens in a sequential manner, but the dependencies remain intact. Now let me go ahead into this. So why do you why do we need so many layers? So you can ask, hey, uh, it's a very simple use case, right? So we just need to have a load. Yeah, we need to load the users. But yeah, it's a very simple use case. So why need to have so many layers, so many classes, and so many dependencies, headache, and all this stuff? So the motive behind having so many layers, or probably defining so many classes, so many abstraction, is the only change that is inevitable, right? So software changes, and there is change every now and then. So the product owner will come to you, and they will just change requirement like anything, and you need to make sure that, yeah, my incremental releases are proper, and also I can assure that any changes to the system can be easily tested and can be maintained. Now, with every change, there can be defects. We end up with some defects, and every defects may lead to side effects, right? Now, if we cannot reuse, that means we are rewriting everything. There are too many God classes, so everyone will be afraid to change. Increase of development times are there, and finally, it will be the technical debt. Now, to basically get rid and to basically minimize the technical debt, we need to be proactive enough, and we need to define our architecture, the application architecture, in such a way that can be easily groomed to accept various changes that comes from the product owners. So what do we achieve after having all these layers and classes and all this stuff, abstraction, separation of concern? So what do we achieve? Number one, the separation of concern. Definitely, we each layer is responsible for doing only one stuff. The presentation layer is meant to display something on the view. The domain layer is responsible for performing critical business logic or even the simplest business logic. And the data layer is only meant to fetch data from any data source, repository, or anything else. So flexibility to change is there. So like I said, I want to replace my network data source with some file data source or vice versa. It's very easy. I don't need to go to each and every file or probably touch some God class, right? And make some modification so as to adopt that particular change. Testability is one of the major factor that we should consider, because if you can see, I told you, we have some model mappers, right, in each layer. So that model mappers helps us in testability as well, because what I am not doing is I am not supposed to mock the entire user data model that is coming from the server and then pass it into all the layers and perform the testing. So data model mappers help us to localize the context. So every layer is bounded by its context. So the view is only concerned about the UI view model. The domain is concerned about the domain model. The data layer is concerned with the data model. So you can see I can easily test the repository by mocking the data model. I can easily test the use case by mocking the domain model. I can easily do some instrumental test, or probably in a presentation layer by mocking the UI view model. So UI data model. So this kind of model mappers are very essential, and most of the times, somewhere down the line, if not early, somewhere down the line, we feel the necessity of this model whenever we start our application testing, or probably even if we start testing at a very initial stage. Consistency is there because we know every layer is responsible for a particular stuff, doing a particular stuff. So consistency is there. Every layer we know there is something, and we can easily go and modify, or probably we can easily identify the area of concern, or probably while we debug. So it is a consistent thing. And if you talk about the uh, the team understanding and all this stuff, so every developer or probably every member in the team speaks the same language, and they know that, yeah, this is the problem area, and this is basically the place where I need to look into. So there is a consistent behavior of this application, and whenever a new requirement will come, you will follow that event data model, right? Event data flow. So that data flows in that direction and data is received in that direction. So there is a consistency. Faster time to market. So whenever you have designed your application in such a modularized way, any increment to that system will basically be very faster, because you will be supported with, because since your application is covered via the unit test, you can easily test by replacing any one of the module, or probably you can try it out. Let's suppose you want to migrate from list view to recycler view in the UI model. Just go and replace it in the view layer. So your domain model as domain layer as well as the data model remains same. Let's suppose I want to migrate from Volley to retrofit. So simple, I will go to the data layer. I will just implement the repository, the network data source. I will implement the data source via the retrofit data source, and I'll be able to replace that. Maintainability is very crucial in any software project, because software grows, and it grows to an extent that we can't even imagine standing on day zero. So maintainability is very important aspect of any software development, and for a very well maintained software is has to be backed by a well defined architecture. So these are some of the stuff that we can achieve when we implement the clean architecture. So these are some of the references. Few of the articles are being published by me, and you can go and have a hit on those articles and see about. I have defined separately the model, the view, the domain, and also the different architectural patterns that is basically meant for the presentation of the application. The MVX, the popular MVX architecture, I have defined all the solid principles that we have talked. It's all in detail. I have published it there. Some resources, the Clean Code Coder blog, and some of the blogs over the Medium, as well as some of the recent articles that I've read. So these are some of the references. And thanks. That's all for today. And let's take some questions. And do find me on LinkedIn, Twitter, Medium, GitHub, and I'll be happy to answer or probably connect with all of you. I think we can take some questions now. Yeah. Okay. So let me take the first question. I think, yeah, it's got the maximum votes. Yeah. So in the event data flow slide, why do I need a use case? Why can't I have a view model talk directly to the repository? Yeah. So that's what I said. It's a very simple use case. And if we are supposed to handle multiple cases, so either what happens is, ideally, I have seen people ending up calling the repository directly from the view model, and their business logic, they are basically shifted either towards the right or towards the left. So either it's the repository that is having the business logic, or it's the view or the view model that is having the business logic. But if you go with the ideal concept of the view model or the presenter should be only responsible for view specific logic, not with the domain specific logic. Same with the repository. Repository should be concerned for fetching the data, not manipulating the data. So that's why whenever we have a domain layer, whenever we used to define a domain layer, we know that the domain is responsible for performing the business logic. So the heart of the software, the heart of the software will lie in the domain. I think, hope that I have answered the questions. Yeah. Going to the next. When it comes to layering the application, if you have multiple feature modules, how do you reuse instances like retrofit, Moshi, etc.? Yeah, very good question. So let's suppose
whenever we used to, because I have the experience of like building application from scratch, as well as dealing with applications which is having a very huge set of god classes and monolith. What happens ideally is like what is my approach, or probably our team's approach had been into that, was basically to have a core framework, right? So we have layered our application into different feature module. Now every feature, at the top of every feature we have a core module, or probably we have why only retrofit on UI? We can have a common UI style guide and all this stuff, right? So we define a core framework, and inside the core framework, or probably the core framework can be further splitted into multiple things. One could be network, one could be related to UI, one could be related to anything. So any common library. So at the top of all those features, there lies some a common framework, I would say, and that framework is shared across all the feature modules. So that's what you can do. Coming to the next, the mapping is done 3 times for the sake of only making the architecture clean. How about performance? Okay. So the mapper is not only for making the architecture clean, and I can see if there are a lot of mappers, there can be a performance headache. But if you think on the larger scale, as I have told, like the model mappers are basically concerned about setting the context for that particular layer, right? So as I said, the data layer is well defined, or probably well equipped to be tested in isolation, in silos, right? I have, whenever I need to test the data layer, I have a user data model. And whenever I will test the domain layer, I will not be concerned with the user model. Had I not been I have not involved the model mapper, what will happen is like I'll be passing the entities throughout my application to the view. So that is not an ideal approach to do, because every time you will test, you will be mocking the entire object of the user, which is basically useless to me except the name in the view. So that's why we have the mapper. And definitely, if we have a very huge lot of complex mapping thing, that will add to performance, but most of the times it will be beneficial rather than performance hack. In some of the projects, the use case usually is forced to have just one method. What's your point of view? Can the use case have more than one method? Okay, so this is also a very important question, because what happens is like, if I talk about the single responsibility principle, and every class doing only one stuff, or probably having only one method, what I think is like, if I say I have a use case, that's why an application is a set of use cases, a group of use cases, right? So an application can have multiple use cases. For our example, it's the loading of the user list. Probably it could be loading some articles and then mapping those articles to some users based on some user ID. That could be one of the another additional requirement. Now, should I have two different use cases, one for loading the list and one for loading the articles? I would say yes. But if I say I have a user table and I have a user address table, and let's suppose these two use cases are cohesive, like cohesive as in they're very closely related, probably I will make them in the same use case. So think about cohesiveness as well as coupling, and then take the decision. For all the cohesive thing, please define a single use case. While mapping between data layer model and domain layer model, are they any different? Maybe a data layer model and domain layer model. I didn't get this question, but yeah, I think I've already answered this. While mapping between data layer model and domain layer model, are they any different? Yeah, there has to be different, because what will happen is you might be needing some extra data for manipulation from the API response that you get, but you may not be needing the same set of data if you want to display that model to the view. So the model mapper will behave accordingly. So that is the answer. Okay, so next question. Can you please give an example of use case, like when we should use this? You can use the use case for any simple use case, any requirement that you have. So there is no any specific example where you need to define a use case. Just think, if you want to follow the clean architecture, and don't think of, because there has been a debate, like we need to have a lot of classes if we adopt clean architecture, but eventually it helps. So whenever you have a problem, it's because my personal view of approaching any problem, I used to define a use case very first. So I used to define a use case, and then I start with the domain. That's what domain-driven design is. So you should start with any use case, and you will require this eventually. Moving to the next, what steps should we do to refactor a legacy activity more than 5,000 lines of production code into a clean approach? Okay, very nice question. And I think this has been a pain for each and every developer who is supposed to refactor a piece of code that is basically the God class. So my approach into that is basically first of all, you should be aware of the design principles, number one. Secondly, you should know that class, what that class is doing, because since it's a 5,000 class, it will be doing multiple stuff. Separate it. So separate the concerns, separate the class and have some delegates, have some has a relationship, do some association, right? So do some association, or then you take up delegate those responsibilities in different classes and see inside that classes whether it is doing similar. So likewise you create a tree of, or probably a dependent hierarchy, right? So your 5,000 line code is now break into, let's suppose, 2,500 line of delegates. Now each delegate can further be broken into that. So that's approach I used to take. But having said that, you should be very careful in doing that, because if that piece of code is not supported by unit testing, it will be very difficult to judge whether your delegation works perfectly or not. So I would say have some integration test in place and then try to refactor it. Sometimes we perform operations that do not involve business rules. A use case would simply invoke the repository. Would it find invoking the repo from our view model in appropriate cases? You can do that, but the problem
Here is like you need to, like, this is a kind of exception, right? So if I say I need to follow clean architecture and there is a separation of concern and this is the event flow or the data flow, I have been into debate for, like, like many times whenever I used to advocate this architecture, people used to come up with this question. But yeah, definitely, if we follow a particular principle, we should be following it to the fullest, what I believe. So I think it's no harm, go via use case. And if your application is not having that much business logic, that means not business critical, it's a very small project, then I think better you can do that, not a problem. But if you have planned to grow your application to a very large extent, it will be a risk going further. Do you think these concepts can be applied to a module used to collect customized UI widgets? Okay, I actually didn't got that, get that, but uh, okay. So we can connect on this, because I think I didn't get this question. Applied to a module is to collect customized UI widgets. Okay, so let me jump to the next question. I will discuss this. Yeah. Apart from co-routines, what other ways to communicate with view model, use case, and use case to repository? So since from use case to repository, you can use any of the, like, concept, like you can use Rx, you can use coroutines, anything you can use. From view model to use case, you can simply use live data. That is because that is life cycle aware and all. So you need to do that. But don't use live data in use case to repository, because at that time then you need to again you need to have, like, the communication thing, that whether a view is alive or not. So that you need to do that. Where can we find download your presentation? Okay, I will upload this in a speaker deck, or in DroidCon it will be updated, and also in my personal LinkedIn, Twitter, I'll be sharing that. Is there an open source code base which built using these topics? Yeah, there are a lot of use case, lot of clean code boilerplate you will find in GitHub. I have one. I'll share it along with the deck. Is it fine a repository implementation depend on a use case or another module? Repository implementation depend on a use case. So why a repository implementation will depend on a use case? Because repository implementation will depend on some that's what, like, see, your use case is a high level module, your repository implementation is a low level module. Now if they are directly linked, they will be coupled, right? So what is the basic like a fundamental of clean architecture is like separation of concern, and also you need to have that abstraction in place. So that's why the low level and the high level module doesn't depend on each other, it depends on the abstraction, so that it can be easily injected, is easily separated. How to differentiate between two classes that implements the same data source abstraction in the repository implementation class? You mentioned that there should be one data source abstract in repository implementation. Yeah, so no need to differentiate, because what will happen is the intention of having a having a data source and then implementing the data source via network data source or a DB data source, there is no such comparison because
See, again, the list of substitution principle. So I have a function called fetch data, let's suppose. Now fetch data is up to the implementation report, the data source implementation that implements it. So a network will implement it in a different way. The DB, the data source implement in a different way. So it doesn't matter whether you're using a data source that is from the network or from the DB. So the repository should know nothing about it, because the repository should concern with only the user data model. So whether it is coming from a DB, whether it is coming from a network, it should not have any concern on that. Will you give any concrete example of this architecture and compare with the bad design to make it clearer to me what the use case is? So think of use case as a kind of piece of code that is basically doing some stuff for you, to be very precise. So let's suppose there is a class, there is a helper class, and helper class is very common. We used to create lots of helper class for our activity, for our fragment. So think of it as a helper class, and eventually think of that helper class to be independent of platform independent, and now move that helper class inside your domain and convert it into use case. So use case is nothing but it is solving a particular thing for you. That's what a helper class do, right? So think of that in that direction. It will be easier for you. If I use Jetpack Compose, can the UI model be substituted the state of the view? Yeah, I think definitely yes. Nice presentation. Yeah, thank you very much. For a business where most of the logic is server side and exposed via web services, the app is configured front end. Is a domain layer required for the app side? Server side, lots of domain logic. If it is entirely if you can guarantee it's 100% backend specific, you can skip the domain layer, doesn't matter. But if you think it will grow eventually, but you then you need to have a domain layer in place. So multiple modules impact the APK size? No, I think it helps reducing the APK size, because if you have a multiple module in terms of feature module, what I can assure is like feature. If you go by module by feature, it will help you in dynamic delivery. And in that case, what will happen is you will be eventually reducing the APK size instead of increasing it. So that is one of the advantages of having modularized layer. You seem to use some layer-based modularization. Instant app push you towards feature models. Creating both feature and layer models can lead to too many models. Could you provide some advice? Yeah. So that's what I told, right? If your features are very much seasonal, and most of the feature are not used at once, you can think of layering by feature, and inside the feature you can have the clean architectural layers, and the inside the layers you can have custom lint rules to avoid the corruption. So you can have that anti-corruption mechanism via custom lint rules. Out of context, not a problem. What are your views on Kotlin multi-platform domain logic can be shared with an Android and iOS and clean architecture? Thanks. Okay, so Kotlin multi-platform domain, yeah, you can share the domain logic across platform, but if you think about clean architecture as such, I think there is no connection with multi-platform. That's what the multi-platform thing, right? So if even if your domain is platform agnostic, so forget about Kotlin multi-platform. So if you can build a domain which is platform agnostic, what you can do, you can just port it to across all the platforms, right? So that way, if you have a cleaner approach to your application, the domain logic, if you want, you can segregate it from your existing application and you can use it across the properties. Wouldn't repo as an interface violate open close principle, where classes should be open for extension but closed for modification? Any change in the repo interface will force this modification for the implementation. But but if you were to change a repo, then probably okay. I actually didn't get a question, but yes, wouldn't repo as an interface violate open close principle, where classes should be open for extension but closed for modification? Yes, that's true. Any change in the repo interface will force the modification of the implementation. So if you change the repo, then it's a change of contract, right? Now your repo, like, it's all about delaying the implementation. So if your repo is
if a repo or probably the interface has too many details, then it's bound to change. So what will happen in that case is like you will be ending up changing lots of stuff in the interface, and eventually it will lead to multiple failures, and that will eventually lead to the like an open source principle thing that you were talking about. But yeah, if you should define an interface in such a way that it should not know much of the details. The details are present in the presentation. Violation of open close principle is common problem in MVP privacy. Yes, that's common. True. Can you explain a bit on the repository pattern? So repository pattern is nothing, but as you can see inside the repository is actually independent of the data implementation, right? So most of the people, what they used to do is like from the use case, they directly call the repository, and the repository implementation itself directly calls the network. So now what happens is like, if we go with a repository pattern, the repository will actually depend on a data source, and data source is nothing but an again abstraction. So the real repository pattern starts when the repository that you're defining is basically talking to a data source, and that data source implementation lies somewhere else outside the circle. So it's about the circle. So further you increase the circle, more abstract it becomes towards the inner layers. So you mean to delegate the repo implementation to the data layer? Definitely, yes. So delegating the repo implementation to a data layer means like I am delegating the repo implementation. Yeah, exactly, to the data layer. Yeah. Do multi-feature module increase build time? No, I didn't observe that, but no, I think a monolith will increase the layer, but multi-feature module will decrease eventually. What would you recommend? Module separation or package separation? That again a topic of debate. So as I said, if you have seasonal features, you should go with layouting the project via some features. But if you don't have seasonal features, or probably features that are uh, things like, you have been using this, and probably some other properties will also be using this, and like later on you need to throw it out, so probably go with the feature. And if you think it should be a part of the common app module, then probably all the features are not non-seasonal, just use it. Just go with a normal like, because you will be saving the custom lint rules and everything. You can directly enforce module restrictions to a particular domain module, right? To what extent we should create uh, multiple modules? Multiple modules, as in if you have multiple features, then there is no extent. But if you directly restrict yourself, your application with the clean architectural modules, you can have data presentation, presentation, domain, data. You can further break it into repository, as well as you can do into data. You can do that. What did you recommend? Model separation or package separation? I have answered that. Where should the data model to DTO mapper lie? Data model to DTO mapper lie in the data layer or in the domain layer? So data model to DTO, it should lie in the data layer, because DTO is something that is your contains some redundant data. So if you talk about the model, so model contains some filtered data. So that should be a part of the data layer. That should, because ultimately the data layer is filtering the data for your application. So it should be in the data layer. Please explain more about the domain layer using some example. So example I have already shared. So all the business critical things will go into the domain, and all the help, all the anything which is business goes into the domain. Anything which is view goes into the presentation. Having said that, the view model will not be responsible for handling the view related logic. The domain specific and the business specific logic will lie in the domain layer itself, and obviously the repository specific logic, as you can say, the mappers and all this applies in the data layer. Thanks, man. Now we have a fan of clean architecture. Same here.